Datadog is a SaaS cloud monitoring and security platform that enables full-stack observability for modern infrastructure and applications at any scale. Provide teams dashboarding, alerting, application performance monitoring, infrastructure monitoring, front-end monitoring, and security monitoring in one tightly integrated platform, plus 450 out-of-the-box integrations with technologies including cloud providers, databases, and web servers. Aggregate all your data onto one platform for seamless correlation, enabling teams to troubleshoot and collaborate together in one place, preventing downtime and enhancing performance and reliability. Get started with a free 14-day trial by visiting datadoghq.com/HanselMinutes. That's datadoghq.com/HanselMinutes. Hi, I'm Scott Hansel, and this is another episode of Hansel Minutes. Today I'm chatting with Nell Shamrell-Harrington. You're a principal software engineer at Microsoft, working in the open source office, and are you a Rustacean?
I am indeed a Rustacean.
What a cool name. So it seems like all the cool programming languages get cool names for their community. Do you have any idea how that happened? Why do Rust people become Rustaceans?
Crustacean, Rustacean, and that's why our logo is, I don't know if it's not our official logo, but there's Ferris the crab, happy little red crab. So that's where it came from. I think it went from Rust to Rustacean pretty quickly.
Mm-hmm. Now I'm a C# person. Apparently, we don't have a cool name, and I always kind of look back on how do people become a C# person or a Pythonista or a Rustacean. I assume that you have programmed in many languages, and this is the one that you found, and that you've decided this is my language. How many other languages do you know?
My first professional programming, I did Java and some other stuff in school, but my first professional programming language was C#, circa 2008, 2009. So bit .NET 2.0 days. So a bit of a ways back. And then I switched to Ruby. I got a job at a startup as an engineer, did Ruby for a number of years, liked it very much. But when I was at Chef Software, which focused on infrastructure configuration management, I started working on a distributed systems project called Habitat, and Rust is much better situated for distributed systems than Ruby is. So I started learning Rust. It was a whole new approach to programming. I didn't have a ton of systems programming experience beforehand, but what kept me writing Rust was the Rustacean community. It is the friendliest, most welcoming, most dedicated to teaching each other, not showing off for each other, teaching each other how to use Rust and how to evolve the language in a better way. So that is really what made me stay in the Rust programming language.
That is really cool. Yeah. I think everyone who loves their language of choice will say that we have such a wonderful community. But I know that Rust came out of Mozilla, which is also notoriously nice, lovely people. So it's good that community is so welcoming. Do you think that this is where you'll stick around for a while? Like you just feel like, yeah, this is my language. It's my favorite.
I think so. It's not to say I don't dabble in other languages. I've done some Go. I've done experiments in Python. I've been experimenting a little bit with capture the flag competitions lately. And when I do script for that, then it's mostly Python. Python's just a little better situated for that, or better suited for that. But Rust, writing my day-to-day code, I really, really like it.
Mm-hmm. All right. So let's make some broad generalizations, because it's nothing like a podcast to bring out declarative statements.
Sounds good to me.
That we can't back up. So we've got Go and Ruby and Python and C#, and we've got JavaScript. These are all different languages that are suited for different things. And I'm sure that we could make statements about those languages, but what do you think Rust is best suited for? If I have a problem, why Rust?
There's a few of them. If you are someone who works on very low-level software where you're interacting directly with the hardware, historically, or working on distributed systems, historically, much of that was done in C++. And I'm not saying C++ is a bad language. I want to make that very, very clear, because there's some Rust fans who do. I'm not saying that. But with C++, even with modern C++ tooling, it's very easy to accidentally bring memory errors into your code, which can cause security vulnerabilities. With Rust, checking for those errors, of your code is built directly into the compiler. You have to intentionally say, I'm doing this unsafe thing in Rust in order to be able to do something that would not pass the compiler's checks. So it's built directly into the compilers. So it's very good for writing very secure software where, every piece of software security is critical, but safety critical software, etc. It's very, very well suited for that. Now, that said, a lot of people have liked the Rust programming language so much, they've started exploring using it in game programming, in game engine programming. I know there's been projects to figure out how to interact with the C++ drivers on video cards using Rust and be able to use a game engine like that. Also, a lot of people, myself included, came to Rust from the Ruby and Ruby on Rails world, very web framework focused. And Rust also has web frameworks. There is Rocket, there is Warp, there is Actic. So if you want to write that kind of traditional model view controller program, or you want a quick working web application that is very secure, it forces you to use good coding practices, it's a good language for that too. It's very young. So we're still exploring all sorts of applications.
Interesting. As you were talking, I'm thinking about when I would use Delphi many years ago, and it would allow me to do inline assembler. And Delphi was like the no memory. I didn't have to worry about memory. It was just very high level. And then suddenly I'd open up some braces and I was doing assembly language. Or C#, where you're just kind of like, woohoo, memory. And then you say unsafe. And then the next thing you know, you're basically writing C.
Right.
Is Rust, it's not garbage collected, right? It is.
That's correct.
You are managing your own memory, but Rust has removed all of the foot guns.
Correct. Remove them by default. If you want to use the foot gun, if you really know what you're doing, you can. And that's using an unsafe keyword and brackets around where you're going to do it. Even then, you're still limited. There are some limitations on what you can do with memory. But yes, Rust, it builds that checking directly into the compiler. And the nice thing about the Rust compiler is I always kind of felt like the C++ compiler was punishing me when I did something wrong or when I had a seg fault or something. And again, not saying it's a bad language, but Rust, the compiler error messages are specifically written. I know a lot of the people who write them, I've written some myself, to guide the person writing Rust code into the best way of writing that code, into the safest way of writing that code. We don't want you to feel bad about yourself. We want you to say, oh, I didn't mean to do that. Make an edit, compile it again, and then be off.
You're on the Rust Foundation, right? You're on the board of directors of the Rust.
I am. I'm Microsoft's representative on the board of directors of the Rust Foundation.
Very cool. So this idea of being friendly is not just kind of cultural in the how we interact with humans, but you're saying that it is a conscious decision on the part of the designers, the compiler writers, to say, I want these error messages to be descriptive and kind and and empathetic.
Yeah. Exactly. There's been enough things to make programmers feel like they're bad programmers, whether it's technical things, whether it's people on Twitter or on Reddit or Hacker News, what have you. We don't want the Rust compiler to be one of those because you belong in programming. We will guide you through programming. Systems programming doesn't have to be super scary if that's what you want to do. Yeah. And this culture is built directly into the tools as well as the people.
Yeah. I came up in a certain generation. I would guess that you probably came up maybe a generation or two later, and then we now have the next generation coming in. And I remember feeling like I was looking at a compiler error message, which I then had to decompile in my head. Like learning the error message was not plain language. It's funny how not far we've come in simple error message language. It would be lovely to work with a language that was friendly to me.
Right. I say I'm an elder millennial. I'm on the cusp, right, between Gen X and millennial.
Okay. I think I'm squarely Gen X, but maybe if I shave, I'll be able to say elder millennial at some point.
Yeah, there you go.
We'll see. Interesting. Okay. So you said, though, that you can do web development, but then you said it was low level. I wouldn't go and say, yeah, I can do C, and I could write a website in C or C++. You don't see a lot of websites written in that. Why is Rust able to have a foot in each world, the low level and the high level?
Part of it is based on people who've come into the Rust community. They say we really like the way, because not everyone comes from a C, C++ background. The early days, a lot of people did, but not everyone does. People were coming from a Ruby and Python background and saying, hey, I've learned Rust. I really like the way I feel when I'm programming it. I like the way I write better code when I'm programming in it. I'd like to take this feeling and this security and translate it to writing in a web framework. There are also ways, there's a WASM, Web Assembly Markup Language. I think that's what that stands for. And that will take Rust code or C or C++ code, if that's what you're used to writing in, and compile it or translate it into JavaScript. And that makes it really easy to run software within browsers, regardless of what kind of browser it is.
Right. So Rust compiles to native code, right? So if I write Rust, I would have to compile it to Windows and then run it on Windows, or I compile it to Linux
Correct.
and run it on Windows. I don't.
You compile to a specific target.
Okay,
That's correct.
Okay, so I compile it to a target, and I would not write like scott.exe in Rust and then run it on Linux. I would have to target Linux in order to do that.
Correct. Yeah, you would either compile it on a Linux system or say, hey, I want. You would specify the target when you built it as x86.
Right. Or x64, or
whatever or ARM, or whatever. There's a lot of targets available.
Okay. And then you mentioned WASM, WASM.
Mm-hmm.
I don't think it stands for anything. I think it means WebAssembly. But you're saying that you can compile Rust to WASM directly, where WASM is the target.
Correct. Yes.
Okay, so Rust is often used for lower level things, but it runs in the web with things like Rocket. If I'm writing a web app with Rust, then I can just render HTML like I do with ASP.NET.
You can, yeah. Rocket has a built-in templating to allow you to do that.
Okay, but then WebAssembly, the rise of WebAssembly is this portable language. I can compile my low-level Rust to WebAssembly and then run it in the browser or in any WebAssembly kind of environment, right?
That is correct.
Now, when you're low-level, though, everything comes down to interoperability with C. Like if you're thinking about C#, you go unsafe, and then you p-invoke or platform invoke. Does Rust interoperate well with C?
It does interface with C well through a foreign function interface, FFI, I believe that is called. And yes, it does interface with it well. And there are people working on ways for Rust to interface with Python and Rust to interface with other languages. Sometimes, a few people have asked me about Microsoft, is Microsoft going to rewrite all of Windows in Rust? Answer to that, I don't think it's anything confidential to say probably not, or I would be very much not. But there are ways to take old C, C++ code, which is working, and interface it with new Rust code.
Yeah, but then I guess you can just say like you can in C, you can say extern C, and then your Rust stuff is callable from C, right? And it'll translate types.
That's correct.
Too. Now, when you're saying low level, how low level can we go? Is this something that's being used in IoT, or can I use it on small devices?
It is. Several people are using it in embedded systems. Again, the fact that there's no garbage collector helps a lot with it working in very low resource environments. So yes, I see people using it a lot with Raspberry Pi, Arduino, and I'm sure there's experimental stuff in the IoT world as well that I don't know about.
So one of the things that happens when you're on these low-level systems is you have to think about, as you said, memory safety and things like that, thread safety. Is the compiler keeping track and warning me that you're going to leak memory here? Like if I leaked some memory, how would I know? Who would tell me and when?
It is possible. There was just an article that I featured in This Week in Rust last week. It is possible to leak memory in Rust. It's much less frequent than it is in other languages. So if the compiler detects when it compiles your code that you're doing something that would cause you to leak memory, most of the time it will give you an alert, or it will error out and let you know that is what you are likely to do. Now, that said, no language is foolproof. People are doing different things all the time and detecting different things. That's why the language is still under active development.
Now, what does that mean? The language is under active development. Like, isn't every language under active development?
That is a good point. Rust, and this isn't unique to Rust, but one of the things I like about Rust is it is developed completely in the open. And anyone who wants a change to be made to the language can open up what's called an RFC, or request for comments. We have a special repo for that. Propose that change, go through what effect it would have, and then harness the context of the entire community in determining, what is this something that would be beneficial to add to the language? If so, what is the best design for it? I don't I very rarely see an RFC come in with a design for a language feature and have that design stay the way it was when the RFC was originally opened, because we need that additional context for the different areas that Rust is used, understanding how it would potentially affect those. And we do come to a better design as a result.
So languages like C# and Python, when they hit a major version, it's a major version. It's a big deal.
Right.
We're on C# 11 now. Everyone knows about Python 2 and 3. You have to really make a decision. Rust is on version like 1.2 something, 1.26?
Version 1.62.
Okay, 1.62. So does that mean that it's actively developed, but it hasn't had any major changes that are going to break us all and cause us to toss code? Do you think about versioning your stuff when you write Rust?
We do very much, and we do use semantic versioning. If it was something that was going to break you, I believe it would be a 2.0 or 2 point something version number. So yes, the goal is to keep things as backwards compatible when you're within the same major version number.
Okay. I'm C#, you're Rust, but we hear people out there talking about Python and Ruby.
Mm-hmm.
Do you put them in a category based on low level, high level, or easy to learn, hard to learn? It seems like it comes down to memory management. People declare if you manage your own memory, that's hard. If you don't, that's easy. Do you think that's fair?
I think it's much easier when you're getting started to not have to worry about your memory. And I do think there's some context if you're running a one-off script, a one-off Python or Ruby script. Depending on what you're doing, you probably don't need to worry about your memory as much as if you were writing something for a distributed system that lots of other services are going to depend on. So it's different. And it's a different mental model as well. When I was writing in Ruby, I was not used to thinking about memory. When I started writing in Rust, in order to understand why Rust was doing the things that it was doing, I did have to start thinking about memory.
Yeah. And of course, for our folks that are listening who may be yelling at their radios or their podcasting device, now, I don't think neither Nell nor myself are thinking it's just, woohoo, do whatever you want with memory. When we say not thinking about memory, I'm not really deeply worried about bytes, a couple of bytes here and there.
Mm-hmm. Right.
When I'm doing some basic work, I'm not thinking list of string versus string array unless it needs to be highly performant type stuff. Are you thinking about that level in Rust all the time?
Rust, for the most part, the compiler makes it so I don't have to think about that constantly. I don't worry about dangling pointers when I'm writing Rust, unless I'm writing in an unsafe block. But if I'm not, I know that the compiler is going to alert me to that. And there's the borrowing system, there's the ownership system, and the intent of that is to prevent you from having vulnerabilities like that in your code, such as a dangling pointer.
Interesting. That seems very, very welcoming. So ownership is the set of rules that Rust uses that decides. Correct. It kind of is a governance system. So rather than a memory manager.
It very much is. Yeah.
Interesting. Can you explain a little bit more about ownership and borrowing? Because that seems quite unique.
Right. So the idea with ownership is that when you have a variable, that variable has a value. Only that variable has access to the value within the heap or within the stack, wherever it is. Mm-hmm. Now, if you transfer that value, let's say I assign it to another variable, the first, let's call it variable A and variable B. And let's say I assign the value that's in variable A to variable B. Variable A will no longer be able to access that value. I don't want that value to be assigned to another variable and still be able to change it. Again, that's a potential security issue. So that is the ownership system. Now, there are things like borrowing where something can, have access to that value. Sometimes you can mutate it. Sometimes you can't. By default, variables in Rust are non-mutatable. You have to explicitly say you're allowing mutating of it. But borrowing is a way that I can access that value, potentially use that value in another function, but still have the overall ownership stay with the original variable. And if the original variable is deleted or goes out of context or is dropped, I'm not going to be able to access that borrowed value anymore. So it's forcing, it's being intentional for you. It's forcing you to be intentional with the way your program interacts with memory in a way that I wasn't used to thinking about before I was writing in Rust. And then I took a C++ course after I learned Rust and realized, this is why Rust does the things it does. Yeah. This makes much more sense now.
That is a really interesting way to think about it. It is very intentional. I think with garbage collection, there's a lot of implicit things like, we left the scope. No one's looking. You haven't paid attention to that variable. We'll clean up.
We'll clean up after you.
implicitly
Yep.
after you. Which is kind of a hotel model where it's like, I've thrashed the place. Someone's going to come and put it back the way it was before. This is more of like an Airbnb model where there's an owner. We know who the owner is. We're going to give you some temporary usage of this space. We'd like you to put it back the way you need to. And then when you return it, we'll do whatever tidying up. Unlike C and C++, where I'm always wondering, like, oh gosh, who cleaned that up? Who owns the malloc and who owns the free?
Yeah.
Interesting. Ownership and borrowing, taking and giving back. Is this a unique thing to Rust, or is this a computer science thing that's happened for years that I'm just learning about on the show?
It is unique to Rust in that it is so user-focused, I believe. Like, I'm certain there's been experimental languages that explored this prior to Rust being created at Mozilla. I'm certain there are. I think Rust has done it in a way that is much more usable than other languages, and in a way that people have latched onto it in ways they have not latched onto other early experimental languages.
Yeah, it is tough nowadays to say that someone invented something. Like you look at like async and await,
Right.
and you say, well, this person invented that for C#, and then it became a thing that we put into JavaScript, and then a thing. But then you go and find a paper that was written by the ACM in 1959.
Absolutely.
And you discover the same thing. Now, there seems to be a race to find out who's going to be the new C language. And one could argue, one has said that maybe it's Rust and maybe it's Go. But you've said that there are some big differences between Rust and Go.
There are. And again, just making it clear for your listenership, I'm not saying Rust is better than Go or Go is better than Rust.
We love our Gophers.
Exactly. Yeah, we love our Gophers. They're cute. Gophers and Rustaceans, they can get along. Go is garbage collected. So if you are running your code in an environment where a garbage collector would take up too much resources or add too much overhead, in that case, Rust might be a better language to use. But what I think it ultimately comes down to is it depends on the skills and comfort level of your team. If you have a team where most people have more experience in Go, you're probably going to be more inclined to choose Go because it's not Go. Or if it's the opposite, people more experienced with Rust or more interest in Rust, you might choose Rust. It's not just what is technically superior for a given problem. It's also what are the skills of the people who are involved in making this piece of technology? How can I do it in a way that is timely for the business and also safer for my users? So it's frustrating to say it depends, but it depends on the context, not just the technical context, but also the social context of where that technology is being created.
So you know how there's language syntax, which are specifically this compiled and it met the syntax, but then there's also idiomatic ways to write things, and you can write JavaScript in any language.
True.
I have realized over the years that I tend to write very C and C++ type stuff, no matter what language I'm writing it in. I wonder if that's a good thing or a bad thing, but I've written Ruby and someone's like, are you a C programmer? And then I'm like, well, 30 years ago? Yeah. And they're like, yeah, I can tell. Is there an idiomatic Rust? Are there people who are comfortable in certain languages that will feel super comfortable in Rust and find themselves writing idiomatic Rust?
Again, it depends. I think when you come from a C++ background and you have an open mind, I do think writing idiomatic Rust, once you realize why it's doing the things it does, is a little easier, which is not to say it can't be learned. If you come from a primarily scripted programming language, you can certainly learn the Rust idioms, but it is going to be, I think, a little more challenging at first, and then it will make sense. You're making me think I worked at a startup once where the startup had switched from Perl to Ruby, and there was an engineer who for years had passive-aggressively resisted that by taking a Perl script, pasting it into a Ruby file, and changing it just enough so that the file technically worked. But it was impossible to maintain. So no matter what background you come from, there's going to be a learning of the idioms, learning of the ways people tend to write Rust code in a way that it can also be edited by other people.
Right. And then I assume that all the while the compiler is being friendly and helpful and there to make things happen for me.
We certainly hope so.
Yeah. So you said that Rust is often used for systems programming, lower level stuff. Let's try to get a little bit more specific because I want our friends who are listening to go and think, maybe I'll write my next thing in Rust. Should they be writing Windows apps or Mac apps? Should they be writing services that have no UI but talk to hardware? Should they be writing microservices that run in Kubernetes?
You can do all of those. I would start with writing command line apps. I honestly think that's a good place to start. You can do that on Mac. You can do that on Windows. You can do that. One of the things I like about Rust is it works quite well on Windows. You can do it on Linux systems. That's where I personally would start. And you can see the ways you can interact with threads, with pieces of hardware, etc. In a way, I think that's a little easier to grasp than other contexts. That said, if you come from a web programming background, you might want to start with a Rocket app or something to that effect, because it's similar. You're learning Rust in the context of what you're used to.
That's a good idea. And then I also wanted to point out that Rust is very reliable around thread safety. Memory safety
Correct.
and threads were not really thought about a lot in the 80s when I was learning to code. And thread safety is thought about at the compiler level. Is that true?
That is correct. Yes.
Wow.
We don't want multiple threads to be accessing the same value at the same time and getting into race conditions. So the compiler detects if that's likely what you're doing.
Yeah, we talked about that term I didn't define earlier called foot guns, the idea that you could shoot yourself in the foot because you have this very powerful thing. Rust is very powerful, but you're saying it's actively working against you hurting yourself because it guides you.
Correct. It guides you. Yeah.
Where do you recommend that folks check out to learn more about Rust?
There's a few. If you like to learn by reading, I recommend Googling the Rust book. That's the classic text many people start with. It's available free on the Rust language website. If you like to learn by doing, there's a series, or both. There's a series of exercises on GitHub called Rustlings. And what it is basically is it's a command line app. You're faced with some tests. Those tests are failing. You fix it with some Rust code, and then you move on to the next challenge, and it introduces you to all the concepts as you go along. For me, that's personally the way I like learning, but I might read the first 8 chapters or so of the Rust programming book. That'll give you a bit of a reference, bit of a mental frame, and then go into Rustlings. And that will reinforce those concepts really quickly and prepare you for the more advanced things that are in the later chapters of the book. Also, I run the newsletter This Week in Rust, which highlights all the goings on in the Rust community every week. And we always include tutorials. And the nice thing is, even when I feel like I already know a concept, seeing a new tutorial someone has written that explains it in a different way helps me understand it better, and it helps me have another resource for explaining it to other people when they are potentially struggling with that concept. So I would check out the Rust book, the Rustlings exercises, and This Week in Rust.
Very cool. Well, thanks so much for chatting with me today.
Thank you so much for having me. This was a lot of fun, and I hope we can collaborate in the future.
Absolutely. We've been chatting with Nell Shamrell-Harrington, Principal Software Engineer at Microsoft, member of the Board of Directors of the Rust Foundation, and proud Rustation. You can follow Nell on Twitter and everywhere that you find your social people. This has been another episode of Hansel Minutes, and we'll see you again next week.